Till now, we have learned about object-oriented programming concepts such as class, object, inheritance, polymorphism. Then we learned about object-oriented design principles, solid principles. Then we saw how to draw class diagrams. And now we will proceed to coding implementation, programming implementation of all these concepts. So we are going to do this programming implementation using design patterns. So when we talk about implementation of object-oriented concepts, we are going to need a language, right? So I think it goes without saying that let's use Java, because Java suits our interest or our purpose the best. But going ahead of that, I would think that we should use framework rather than a language. Why should one use framework? What is framework? Framework is nothing but a ready-made set of functions, a ready-made set of functionality, which could be ready-made set of classes, set of files, set of programs, right? They are given to you, so it avoids repetition of code. A lot of boilerplate code such as database connectivity or rendering of views, or you could say batch processing or sending emails or something like all these activities, trivial activities. When you talk about, let's say, web development or mobile development, these are trivial activities, connecting to database or sending emails. So framework usually consists of classes which have this functionality. So they save you the effort of writing this boilerplate code. You don't have to write that code. You just have to focus. You can just focus on your application logic. So that is why it is always advisable to use framework instead of a language. The second advantage of using a framework instead of language is that it already implements most of the design patterns that we are going to study in the next set of videos. So let's say you are one of those lazy programmers that you have learned object-oriented programming concepts, solid principles, even you have studied design patterns, let's assume. But when it comes to development, you're not that vigilant, or you're not that much enthusiastic about implementing all the patterns all the time. So when you use a framework, the advantage is that you don't have to do much. The framework itself is already implementing most of these patterns directly or indirectly, either behind the scenes, or you can sometimes even see them in the code provided by framework. So that's the beauty of it. Just by electing to use a framework, you're already implementing most of the design patterns that we are going to talk about. Of course, as your application logic demands, you can also implement those patterns or principles while you code, and that's what we are going to study. But using framework also gives you that benefit. When we talk about web development, most of these frameworks implement a very popular pattern, design pattern called as MVC. MVC is not any other design pattern. MVC could be called as pattern of patterns. It's a compound pattern. It's that it uses many other design patterns in itself. That is MVC. MVC stands for Model View Controller Pattern. Let's take an example of any web application. Every web application, or for that matter actually even mobile application, every application essentially will have three things. Those three things are, it will have certain user interface, right, through which end users will interact with your application. It will certainly have some data which needs to be persisted in some kind of database. And third, it will have its business logic, the algorithms, the strategy of the application, right? So data is represented in your application, in your MVC, by models. User interface is represented by views, and controller is basically where you use your business logic. Although it's not that straightforward. I mean, business logic sometimes is kept partly in models, partly in controllers, and also you can write your own service classes which are used by controller. So this business logic, I won't say it's always inside controllers, right? But general definition is data represented by models, user interface represented by views, and your business strategy or business decisions are usually made with help of controller. Controller will be like a director of the movie. He will get the task done either by the help of models, some other service classes, some external libraries, or call it what. In your web application, client, that is the end user, has this browser where he says, let's say www some application name /home. So it is making a request for the home page of that application. This request, HTTP request, is received by a controller, right? A controller determines which view needs to be served to browser as a response to this request. Then the controller also decides for rendering that particular view what data is required. So it contacts the model, gets the data from the model, and creates that view, finally sends back the HTML, the markup, the final view as a response to the browser. So see, controller is more like a coordinator between your model and your views, right? Model's primary job is to persist the data in some kind of database, some kind of data store. So models are usually classes which represent entities in your database, that is called as, suppose it is RDBMS, then there are tables. So there will be classes which represents models which represent these tables, right? So they will usually give you CRUD functionalities, that is create, read, update, and delete on your data entities. Controller's job is to, as I said, act as a coordinator between model and views, right? Now, to further explain this phenomenon, I'll take a simple example. Let's take a simple example of user sign-up process, right? So in the browser, right, when you say sign up for a particular application, you go to the path of sign up. You see this form, right? Username, password, email, and some columns, and then there's some button. So now, when you click this button, controller receives this data, the sign up form details, right? It manipulates a model of user. So there will be some model of user. Controller uses this data to create an instance of user model, and model will create an entry in the database, right, for user table. With the data that controller passed to the model will create an instance of a user. In the process, let's say this model also generates a confirmation link for that user. Model will send this confirmation link back to controller. Why? Because now we need to send this confirmation link to the actual user, let's say via email, right? So what controller will do is that either controller or with the help of some service or library, controller will get this confirmation link from the model, generated confirmation link, and it will have some logic to send the link to the user, either through email or some other medium, right? And after sending it, the controller will update a view to the end user using a view that confirmation link is sent. Right? Some message here. Your confirmation link is sent via email, for example. right? So here there are two views. First view, so first you said I want to do sign up. That request went to controller. Controller simply rendered a view, the empty form, right? Once that form was filled and you said submit, controller passed that data to a model. Model created an instance of new user, generated the confirmation link. Confirmation link was sent to controller. Controller sent back a new view with displaying the information such as, so basically controller first sent that confirmation link via email to the user and updated the view saying that a confirmation link has been sent to you on your email ID, right? This is how it is happening. Now, how MVC is beneficial in this scheme? Let's say we want to change the view. We want to change the UI design of the form. You want to display this send confirmation link message in some other design, right? So I change these views. The logic of it is present in the view files. So I change that using some CSS or some technology. But that doesn't change anything in your controller and in your model. Model still generates the confirmation link. Controller still sends the confirmation link via email. There's no change. Only view was changed because we wanted to change the UI. So see, they are very loosely coupled. So change management is easier. Now take another example. Now let's say model was generating the confirmation link, but it was really long. Like let's say the link was about 100 characters. Now, so we decided that model should generate a small confirmation link, right? So we changed that logic in the model. Again, is there any change needs to be done in controller? No. Controller just gets that link and sends it over to the user over email. View, nothing. View will just display the message, confirmation link sent. So no change in controller or view when we change the model. Now let's say we want to send the confirmation link instead of email, we want to send via SMS, right? We are taking the phone number. The only thing that will change is the way controller is sending the link. Instead of send email, it will send the SMS. But do we need to change the way model is generating the link? No. So controller will just make sure that the confirmation link is sent to your phone. So that slight change of message will happen in the view, which controller will send to the browser. So you see, they are very loosely coupled. The views, controllers and model, they are doing their separate jobs independently of each other. The benefit of which is one, change management is easier. As we saw, when we change views, we not need to change controller or model. Or when we change model, we not need to change controller or views, right? Another benefit, usually in an application, when the project is very complex and large, designers and UI developers will work on views without bothering about the business logic details or database model details. So they will keep on working on views because views are very loosely coupled. And server-side programmers can work on your controllers and your models and further service classes which are actually utilized by controllers or models both. So there's a clear separation of work. Presentation layer can be worked upon by UI designers, UI developers. Whereas your server-side layer, here also you can decouple it, like database administrators or database developers can work on models and server-side programmers could work on controller and services. So there's a good separation of division of work that is possible by using this MVC architecture. In general, most of the popular web development frameworks use MVC pattern. Some examples would be Spring MVC, Laravel, which is based on PHP, ASP.NET MVC, which uses C#. Then you have Ruby on Rails, which uses Ruby. And what we are going to use for the demonstration of our design principles coding, we are going to use Grails, which is a Java-based framework which uses a language called as Groovy. It is very similar to Java. So all these frameworks use MVC design pattern or MVC architecture, right? In all of these frameworks, you will find certain design, certain directory structure, certain artifacts which are common. Few of them, there will be some configuration file. So in every framework, you will have some configuration file. The name of the file will differ from framework to framework. Spring has pom.xml, Rails has some YML, Grails has some application.yml. They will have different file names according to the framework and language. But the configuration file will be there. So this configuration file will have settings such as email settings from which account your web application will send emails, database configuration settings, if you are using memcache or caching mechanism or search engines, those settings. Then you will have directories for storing, creating models, directory for storing or writing controllers, directories for generating view files. Then you have assets, where you will have assets directory will have subdirectories such as images, style sheets, JavaScript, right? And all those things. And you will have some directory for storing services. Services will have classes which will contain your further business logic. Services will be mostly utilized by your controllers or your models, right? So this is a general project structure that you will find in any MVC framework. It does not matter really which framework you use. The architecture is more important. So MVC is common. So once you learn, let's say, this framework, you can easily learn any of these other frameworks because they are all following this MVC architecture. And Laravel will have these directories and these files. And exactly same, Rails will also have these files and directories and any other project. So it is, the learning curve is very less. The learning curve is very less once you master any of the MVC frameworks because they all adhere to a certain architecture, right? Now, to round off the discussion, I'll just give you a simple example. I told you in the beginning that one advantage of using this MVC architecture is that it implements certain design pattern itself. You don't have to worry about it. One example is singleton design pattern. You remember when you were in college and when you learned Java, right? We used to create that those AWT and Swing based desktop applications using Java. The forms, Java forms, AWT forms, right? And usually the college project would require us to connect those forms with some database, say Oracle, right? So you remember we used to establish JDBC connectivity using that JDBC connector class. We used to create this con object, connection object with new JDBC, right? And give the username and password. And then on every of those forms, right, you used to say connection.open and connection.close, right? And in between you have to perform some SQL queries while the connection is open and before it closes. Then somebody told us that no, instead you should extract out that connectivity code, put it inside a class, singleton pattern, right? Create only one instance of that database connectivity class and just use that instance in all these forms, pass it around the forms, right? That is one example of singleton pattern. But when you use any of these frameworks, right, I said that you have to specify your database settings in your configuration file. Like you can see one here in the Grails app config application.yml file. See, so I'm using this framework called as Grails, as I said, We are going to use Grails to demonstrate all the programming that we are going to do in order to implement our design patterns, object-oriented design patterns. So as I said, in this application, in this framework, there's application.yml file where you specify your settings such as database and everything. So I'll show you. See here. So you specify your username, password, your database name. In this case, it will be sample app and driver name, right? Now, remember that we were supposed to implement this singleton pattern for database connectivity, right? Create only one instance of the database connection and open and close it as and when needed. But the framework, all these MVC frameworks that we are talking about, they do it internally. You don't need to worry about anything. All I need to do is see here I need to create a model class, let's say forum, and I just need to create, let's say, new forum object. And as soon as I do it, the framework creates the database connection object for me, opens the connection, does the fires SQL queries on the database, and closes the connection. So the singleton pattern is definitely implemented, but I don't need to do anything. The framework is doing it for me. So that's the added advantage of using any framework for development. It itself implements a lot of patterns while in its structure, the way it takes care of the boilerplate code for you. Now, one more thing I wanted you guys to see is that the directory structure of this general framework. So, as I said, there is a assets folder where you will have your images, your JavaScripts, your style sheets, right? Style sheets will generally be CSS, JavaScripts, and your images, icons, and everything. Then you will have your configuration folder. So this file has all the configuration of email, databases, and everything. Uh, then you will have a folder for controllers where you will have all your controllers, right? One specific type of controller is called as router. In this framework, it is called as URL mapper. So where you will specify your routes. So your home route, that is which fires up your application, like www.application.com, will be served by main controller's index method. So I'll come to this uh, in detail when we talk about our programming examples. In this framework, they are calling it as domain, but this is your model folder where you will store all your models, where you will create all your models basically, right? Then you will have a views folder where you will create all your view files. Generally, these are uh, they contain HTML markup, yeah, and along with that they will have some server side code. So here it is GSP in Grails, that is Groovy Server Pages. In Spring, they will be JSP, Java Server Pages. In Rails, they will be uh, HTML.erb, Embedded Ruby. And then in PHP, HTML.blade or something like that. And in ASP.NET, there will be something else. So, but they're so identical that all the views will be HTML plus some server tags, some server little bit of snippets of server side code. Yeah, so it's very common in all these frameworks. So the point of showing you this directory structure is that no matter which framework you choose, be it Laravel, Rails, ASP.NET, or Spring or Grails, will have similar kind of directory structure for you, similar kind of folders, similar kind of files. Yeah, they will have certain changes of syntax here and there, but conceptually they remain the same. And yeah, they're just great to use. And in next video, we start discussing object-oriented design patterns. We start with our first pattern in the next video, and I'll explain the pattern first on my whiteboard, and then we'll see how to implement it programmatically using our tennis complex problem statement, right? So I'm looking forward to discussing this object-oriented design patterns with you.